in our previous video, we worked this out. We used u for ln x and dv for x. What we got when we did this integration by parts was x squared ln x over 2 minus x squared over 4 plus c. Now, let us consider using u for x. So, our u is x. So, our dv is ln x. Alright? When you differentiate x, you get 1. So, our du is 1. And then, to move from dv to v, you integrate ln x. So the integral of ln x is x ln x minus x plus c. That's the integral of ln x. Now, let's see how it goes. We have the integral of u, which is x, dv, which is ln x, is equal to u, which is x, times v, which is x ln x minus x. So it's x ln x minus x. We'll not use a constant of integration here until we finish. That minus the integral of v, and v is x ln x minus x. du is 1. Now, let's see how this goes. X times x, that's x squared. So we have x squared ln x minus x minus. Now we have the integral of, in bracket, x ln x minus x. Let's open the bracket. That's the integral of x ln x. Then it's a minus negative, so you'll say plus the integral of x. Alright? Or what you could consider is that you're subtracting all of this in the bracket. You put the bracket here and you find the integral of x ln x minus the integral of x and close the bracket. Then you open the bracket after. You could consider it that way. So you have x squared ln x minus x minus the integral of x ln x plus, now negative and negative will give you a positive, plus the integral of x. Now this is the integral of x ln x. But notice something here. We have the integral of x ln x here and the integral of x ln x here. The same things. So what we do here now, let us add the integral of x ln x to both sides. You have the integral of x ln x plus the integral of x ln x, right? This is the new integral of x ln x that you just added. Is equal to x squared ln x minus x minus the integral of x ln x. Remember, you're adding integral of x ln x to both sides, so let's add it here, plus the integral of x ln x. And then we have this now, plus the integral of x. Now what you notice, negative integral of x ln x plus integral of x ln x. That is gone. Now here, integral of x ln x plus the integral of x ln x will give you 2 integral of x ln x. Now this is equal to x squared ln x minus x. Then what happens here? Plus the integral of x. Alright? Now, over here, you have x squared ln x minus x plus, what is the integral of x? It is x squared over 2. Alright? In other words, half x squared. See that? Now, just to double check here. Let me just double check something. We have v dv as this. Then the integral is x ln x minus x plus c. Just to make sure everything is okay. X squared. Oh, okay. I see something here. One thing was left out. U is multiplied by v. All of v is this. So the x must multiply this x and it must multiply this x as well. So this x here should have been squared. So it's x times x gives you the x squared ln x, and the x times negative x gives you this x squared. Alright? So here now, I just realized that that was left out. So you have this supposed to be squared. This x is supposed to be squared. This is supposed to be a square as well. So this is our squared. Now, simplifying, this is x squared ln x. You have negative 1x squared plus half x squared. If you have negative 1 plus half, that leaves you with negative half x squared. See that? Fractions. Negative 1 plus a half will give you a negative half. Now, here, this is 2 integral of x ln x. So let's divide both sides by 2. The integral of x ln x is equal to x squared ln x over 2 minus, when you divide half by 2, you get a quarter. So it's a quarter x squared, which you could very well write as x squared over 4. Alright? X squared over 4 and plus the constant of integration. Let's compare this with what we had before. X squared ln x over 2. Yeah, x squared ln x over 2 minus x squared over 4 minus x squared over 4 plus c. So you see, we got the same answer. It's just that what happened here is that when you choose u for x and dv for ln x, you have a lot more work to do in order to get the solution. But you have less work to do when you use u for ln x and dv for x. But both of them come to the same solution. It's just that you have more work in this particular case.